You can't judge a book by its cover, and apparently you can't always tell the health of a river just by looking at it. Which is why we're here, to get down and get wet. This is one of between 4,000 and 6,000 sites throughout Australia that will be checked out by the year 1999. The initiative is called the National River Health Program, and the tool that has been designed to implement the initiative is called AUSRIVAS. That's not how I would have spelt it, but anyway. This is Richard Norris, ably helped by Sue Nichols. We're going to be taking some samples of the water to determine just how healthy it is. So Richard, what are we looking for?
Bugs.
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 Okay, I suppose we better backtrack a little bit to put ourselves properly in the picture. Basically, as we all know, life on Earth depends on water. But the way we humans have been living has compromised the health of our rivers. The water in our rivers has been polluted, depleted, made unusable by salinity, toxic algae, and other problems. The National River Health Program is a federal government initiative of which a key part is AUSRIVAS. AUSRIVAS is managed by Environment Australia in conjunction with the Land and Water Resources Research and Development Corporation. It's a big mouthful, but it's a big job. Wow, kinky. The aim of the NRHP is to assess the health of our rivers and, once we've worked out where the water is degraded and why, to begin the huge task of rehabilitation and management. So this is our stream and we're going to check under the hood, or give it a medical, as it were?
Well, to give it its correct term, biological monitoring.
Oh, I like that better. That's where the bugs come in.
That's right. And what we're going to do is get into the river and take some samples. And a healthy river would have lots of life in it, so we'll census those samples to see what sort of animals are there, and that'll give us an idea about how healthy the river is.
A census? What were those bugs doing on the night of August 6th, and what religion are they?
Well, probably not in that much detail. Healthy water supports life in abundance. Biological monitoring means, to a degree, collecting samples and conducting a census of the life that they contain.
Bugs, more properly macroinvertebrates, can by their presence or absence tell us a lot about what's happening in a stream over time. Biological monitoring with macroinvertebrates has the advantage of being cheap, quick and easy. It doesn't require expensive equipment, and thanks to work that's been done here, in Britain and the USA, the use of bugs as bioindicators has now become quite accurate and sensitive. So the purpose of this video is to demonstrate the correct techniques for AUSRIVAS sampling from macroinvertebrates.
Aquatic scientists across the nation, including those here at the CRC for Freshwater Ecology at the University of Canberra, have developed a computer model, a reference if you like, which rates each river site that we sample in terms of human impacts. The model has been developed from about 2,000 sites sampled right across Australia between 1994 and 1996.
Oh, I see. So this is the model that tells us how many bugs are in each sample?
Well, not just how many bugs are in each sample, but what different kinds of bugs are there as well.
Oh, there's different kinds of bugs. This is getting better and better.
That's right, and some of them are very sensitive to pollution.
Oh, we'll try not to offend them.
The model grades each invertebrate family according to its sensitivity to pollution. A grade 10 is high sensitivity. A grade 1 is high tolerance. What we find will tell us a lot about the health of the site we've sampled.
Obviously. First we've got to get these big rubber things on so we can practice some safe river walking.
That's right. But if the computer model tells us, for example, that there should be mayflies in the river here, but we don't find any, then that tells us that it's possible that the section of the river here is suffering from trace metal pollution.
What, here? It's so clean and pristine. Oh, there's the Exxon Valdez.
Well, it could be, and that makes the point that elsewhere in the catchment we don't know what's going on. And upstream might be a whole range of things that are causing impacts down here.
So you've got people all over Australia taking samples from streams and comparing them with your computer model, is that right?
That's right, that's the way it's done. Click on the icon that will have been downloaded with the computer model from the website. And once that's up, you can load the data from your test site. First of all, the bug data, then the physical and chemical data. And once they're in, you can run the model. This time you need to enter a password, then select the state from which your test site's data have come, then the sort of model that suit your test site data, and run the model. The outputs from the model are described well in the manual that's on the website for AUSRIVAS. At the main screen is perhaps the last one, where we can see the ratio of the observed to expected taxa, the ratio of the observed to expected signal index, and the bands of river condition for each of the test sites that you've sampled.
I haven't got a password.
Well, if you call Environment Australia or me at the CRC for Freshwater Ecology at the University of Canberra, we'll fix one up for you.
All right, I might do that. And I can use a number too, like a PIN number, like 007, licence to wade.
If that works for you, that'll be fine.
All right. Now this is crunch time now. We're out in the field. We've got the silly gear on. What do we do?
Well, that's what this video is all about. And the workflow is quite simple, really. And we'll go through it step by step.
All right.
You choose a site. Have the right equipment. Observe a site. Next comes sampling techniques. Sorting your samples. And back in the lab, identifying your samples. Data entry and checking. Then running the AUSRIVAS program.
Do you think we could fit coffee break in there somewhere?
I'll tell you what, why don't we just do it?
Good, because I'm sick of being warm, dry and comfortable. Let's get in there.
Let's walk down and have a look at things.
So what do you expect to find here?
Oh, all sorts of bugs.
The NRHP and the CRCFE, and if you've been paying attention, you will know what that stands for, have together developed a standardised method for assessing river health. If the growth statistics from thousands of nationwide sites are to be consistent, then obviously a uniform monitoring method has to be employed. So Richard, can people do this any time of year? Can they say, oh, nothing on TV, I might go down and monitor that stream?
No, they can't, Vince, because the national sample might be compromised by seasonal variation. So the only times we can sample are in autumn or in spring, like now, and certainly not after heavy rain when the rivers might be swollen and dangerous.
All right, so we're here at a pretty good time now. We've got our monitoring gear on, we're ready to go. What do we do?
Well, the first things have already happened back in the lab.
Already happened? Now, before a knucklehead like myself became involved in this great project, most of the preparation work had already been done. This is the field sampling sheet that you download from the AUSRIVAS website. It's called a field sampling sheet because it's the sheet you take into the field to record data when you're doing your sampling. Get it? Field sampling sheet. Brilliant. Make sure you download the right field sampling sheet for your state, and it's very important that all your monitoring team use the same form and the same format. Isn't that right, Sue?
That's right, Vince.
As you were. Then the maps come out. The spot is chosen, the route is selected, permission is sought if necessary, all the gear gets assembled. Then I suppose you all decide to meet at a certain spot at a certain time, and please be careful out there, gang. If you're driving, make sure you have a car. Thank you. Okay, I have my field sampling sheet. What's the first thing I need to look at?
Well, we need to start filling this out, and the first things we need to look at is how we got here, whether we need permits to get down here, whether we need keys to get into the site, that sort of thing. And we need a sketch map of how we got here as well, so we can help people that come after us.
Great. Can I borrow a pencil? Thank you. Okay.
Okay, we need a sketch map of the site.
Sketch map.
We need to record the site number.
Yeah.
And the exact location, so that when we get back to the laboratory, we can ring up the local gauging station to get discharge data for the stream.
All right, we're all set. Let's go, let's start waiting. Let's go.
Not quite. First of all, we need to have a look around the site to choose the exact place at which we're going to sample. We need to be away from local erosion spots, places where cattle might be wandering in and out, or perhaps cars are driving across the river, that sort of thing. And of course we need to look out for safety issues like sudden drop-offs or maybe even crocodiles.
Crocodiles?
Well, maybe not so much a problem down here, but certainly for those sampling in Northern Australia, it's a major safety issue they have to be careful of.
Okay, we might just stay around here. We don't want to see no crocodiles. This looks like a pretty good spot here, Richard. So I bet I know what comes next. Don't tell me more paperwork, right?
Remember the flow chart.
Observing the site. So what are we looking for?
Looking at.
Looking at, right. Looking, making notes. Is the river small, medium or large? Above me, is the canopy open or closed? Do stock graze on the surrounding land? And the stream itself, is the bottom sandy, rocky? Is it fast flowing, slow? Is that a deadly snake or a crocodile?
You need to make sure that your writing is legible.
Okay, I'm doing my best. It's a bit awkward.
Well, there's no sense going to all this trouble if when we get back to the lab other people can't decipher your handwriting.
Okay, boss. So I have observed.
Well, let's get into it then. You got the equipment?
The equipment.
We use a standard 250 micrometre mesh net for all sampling. Always check the net for holes before packing it, and always wash it thoroughly to make sure there's nothing left over from the last trip. We need bottles and jars with lids and labels on the jars, not on the lids, which can get mixed up. We take water quality measurements in the stream before we stir up the stream, and we collect the water sample for analysis on the stream bank and also back in the lab. And before taking the sample, we make sure that we rinse the bottle 3 times and then fill the bottle up, leaving an airspace for freezing. When we measure the flow of the river, we do that at the exact place where we're going to collect the animals.
Now can I get my sample?
First of all, we need to take some measurements.
All right.
When we work on streams, we normally work in pairs. First of all, it's much faster like that. When you get used to it, it should only take about 20 or 30 minutes to do a whole site. And then again, there's the safety element.
Okay, well I'm going to measure the stream, including the distance between the banks.
We also need to estimate the width of the riparian zone.
I knew that.
The riparian zone is the area from the edge of the water to where the stream interacts with the vegetation.
All right, so would you hang on to that tape measure for me? Thank you very much. And away we go.
You'll need the tape measure for the first few sites until you get accurate at estimating distances and areas.
Watch your step.
Also indicate the percentage cover for the riparian zone and what type of vegetation is present. If you can name the species, that's a real bonus.
How's that?
That's 11 metres.
11 metres.
What we want to do is sample 2 habitats. The edge, slow-flowing areas, including macrophytes perhaps, and the main channel. In this case, riffle zones, but in other states it might be other habitat types. You'd need to check the AUSRIVAS website for the habitat specific to your state.
All right. The channel. How am I doing? Huh?
No.
Oh, you better show me then, sorry.